In this video tutorial, we will discuss the differences between physical versus chemical change. Alright, let's do a brief review of grade 9 science. Physical versus chemical change. When we talk about physical changes, we are referring to those that affect the appearance of a substance but not its chemical composition. So ice, liquid water, and steam look very different from each other. But in all three cases, we have the same particle, H2O, the water molecule. So they may look different physically, but chemically they are identical. So when we talk about phase changes, going from a solid to a liquid or liquid to gas or anywhere in between, we are talking about the same chemical composition. We're only changing the distance between the particles themselves. And so all phase changes are physical changes. When we dissolve a substance, so we dump a lump of sugar into water, the water molecules start to spread out the sugar. In the end, sugar tastes sweet. Sugar water also tastes sweet because the molecule structure has not changed. They are still sugar molecules, just surrounded by water molecules. The water remains as H2O and the sugar stays as C12H22O11. So again, the only thing that changes here is the distance between the particles. The chemical composition remains unchanged. So dissolving is still a physical change. Pounding, scraping, stretching, ripping, denting, cutting. These all change the appearance of a substance, but they do not change the particle itself. So when I tear up a piece of paper, it's still paper particles, it's still paper molecules. I didn't break up those chemical bonds, I didn't make something new. Because that would be a chemical change, where a new substance with a different chemical composition is created. So for example, electrolysis of water. If I apply an electrical voltage to water, I can separate the water molecules, H2O, into its component elements, oxygen and hydrogen. So I've gone from one type of particle, H2O, to two types of particles, O2 and H2. Now during this electrolysis process, I know that this side is the hydrogen side and this side is filled with oxygen gas. I can tell that because, take a look at the formula, H2O, 2 parts H, 1 part O. There's always twice as much hydrogen as there is oxygen. So just looking at the volume, I can see that there's twice as much gas here than there is over here. So this must be the hydrogen side, this must be the oxygen side. Meanwhile at the bottom, we have water molecules. Now, what proof is there that the gases produced during electrolysis are no longer water molecules? Because when I add electrical energy to water, I make gas, but when I add heat or thermal energy to water, I also make a gas. How do I know that this gas is still H2O, while these gases are no longer H2O? Well, we can test out their properties. So for instance, if I had a glowing splint, so a piece of wood that is just glowing, it's not on fire, but it's just glowing, and I dip it into pure oxygen, well of course fire needs oxygen, by dipping it in, this piece of this glowing splint will burst into flames again. But if I tried to do that in steam, I'm pretty sure the glowing splint would not burst into flames. If anything, it would probably go out. So oxygen and steam have two different properties. You put a glowing splint into oxygen, it will burst into flames. You put it into water that is gaseous, so steam, it will not. Two different properties, therefore it must be two different substances. Now, if you try to put a flaming splint into hydrogen, the hydrogen will explode, making a popping sound. But if you put a flaming splint into the steam, it's going to go out. Once again, two different properties for two different substances. So to help you determine if a new substance has been created, these are a few signs you should look out for that may indicate that a chemical change has occurred. So if you have energy being released or absorbed, so like when you're burning something, we call that a combustion reaction, or maybe a cold pack that we use for first aid scenarios, it absorbs energy so it feels cold, or if there's gas being produced, a new color change, or the formation of a precipitate, which is a solid that appears from a liquid. So here we have two liquids mixing together to form a solid powder. Though any one of those signs can indicate that a chemical change has occurred, the one question you must ask yourself is, has a new substance been created? So just because I have a color change doesn't mean a new substance has been created. So take for instance, let's say I had some grape juice. Then I added some more water to it and now it's not as sweet. Then I added even more water to it because I'm a monster. And now it doesn't even taste like grape juice, it just tastes like water at this point. Well, have I changed the molecules? No, it's still just grape juice, it's just being more dilute, more spread out. So even though it has a color change, it's still not a new substance. So in the end, you have to ask yourself, did I make a new substance? All right, so what I want you to do is classify each of these changes as either being physical or chemical. Give it a try. When you're ready, press play, and we'll take it up together. All right, so water turning to ice is going to be a physical change because it's still H2O, still H2O. Wood being burned is definitely a chemical change. The smoke that comes out and the ashes that are left over after the wood has been burned are definitely two different substances than what the wood originally was. Iron turning to rust is also a chemical change. While iron is strong, rust is very brittle. Two different substances, two different properties. Sugar added to water is a physical change. That's just dissolving something. No new molecules are created. Copper metal being bent into a different shape is still just a physical change because it's still copper metals. No new properties there. Water separating into hydrogen and oxygen gas is definitely chemical change. While an aluminum pop can that is warmed above a stove is just a physical change. It is still made up of aluminum atoms. Finally, mixing vinegar and baking soda is a chemical change. This is the typical science fair experiment that elementary students conduct as a volcano demonstration because it creates a fizzy gas, in this case carbon dioxide. So a new substance is created.